Yes, you can start now, ma'am.
Good evening, participants. It is my pleasure to welcome you all to AICTE Atal Training and Learning Academy sponsored faculty development program on leveraging machine learning and data science in healthcare and MedTech, organizing by CSE Data Science Department, Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur. This program, spanning from January 6 to January 11, 2025, promises to be an enlightening journey into transformative power of technology in healthcare. Now, we move to our first technical session of day 5, which will be conducted by Dr. Gajanan Avari. I am honored to introduce Dr. Gajanan Avari, a distinguished academician, researcher, and administrator with an illustrious career spanning over 3 decades. Let me give brief introduction about Dr. Gajanan Avari. He had completed BE from RTM Nagpur University in 1991, ME from Thapar University, Patiala, Punjab in 1995, and PhD in CFD from Sant Gadke Baba Amravati University in 2007. He has more than 31 plus years of teaching experience at UG, PG, diploma, and research level. He has experience of 10 years as an approved principal of NAC A plus grade accredited engineering institute. He is nominated by AICTE as a Margdarshak for NBA accreditation of Menti Engineering UG PG institutes. Empaneled as an expert member, empaneled as an expert member in AICTE expert team for EVC SCH. Nominated by AICTE as an expert in the panel of National Education Policy NEP 2020. He is guiding 3 engineering mentee institutes UGPG as an AICTE Margdarshak and appointed as the Chief Coordinator of Mentor Institute Government Poly Nagpur for mapping with 10 MBIs under AICTE Margdarshan scheme. He has 31 Scopus Index SCI journal papers and 398 citations with H index and I-10 index as 10. He has granted with 5 patents including one Africa and one Australia patent. The commercial product is also developed based on this patent for the industry Mahindra and Mahindra. He is recognized research supervisor for PhD at 4 Indian universities. 24 research scholars completed their PhD under Dr. Gajanan Avari. Presently, 3 research scholars are pursuing doctoral research work under him. Dr. Gajanan Avari is a reviewer of various renowned international journals like ASME, ASCE, and Elsevier Thermal Science. He has executed the various funded projects as a principal investigator and total grants received are rupees 1.14 crore from AICTE New Delhi. He has organized 11 AICTE, IST, SRM University, Atal Academy funded national workshops and 10 international conferences as a convener and fetched the total grants of rupees 23 lakhs. He is instrumental in establishing MOUs with leading industries of the region and the institutes of higher learning. He has represented India in National Education Fair at Colombo, Sri Lanka, and traveled to SEGI University, Malaysia, and Japan on academic assignment. He has generated the IRG of more than rupees 1 crore in last 4 years through consultancy, testing, audit, and mentoring for NBA. He also worked as a BOS member in Goa University, SG Amravati University, and RTM Nagpur University, YCCE Autonomous Institute Nagpur. He is nominated as member in Academic Council at NAC A plus grade accredited institute, BOS member in GH Raisoni University MP, and chairman BOS Automobile and Mechatronics Engineering at Government Poly Nagpur. He is expert in Curriculum Development Committee of Delhi Skill and Entrepreneurship University under Government of Delhi. He achieved awards like ISTE UP Government National Award, Shastri Gaurav Puraskar, Maharashtra Gaurav Puraskar, Aaj Tak National Award. Include there are total 10 awards under him. He has authored total 11 books in engineering and technology domain, and 5 books are authorized for CRC Press, Taylor and Francis Group London. He has developed more than 20 video tutorials, that is e-contents, delivered more than 300 plus invited expert lectures. Under his guidance, there are 6 institutes who achieved NBA accreditation under his monitoring. He was thricely invited by Prasar Bharati Akashvani Nagpur radio station for an interview. Dr. Gajanan Avari sir, it is our immense pleasure that you have accepted as an expert in our FDP. Now I request Dr. Gajanan Avari to share their valuable insights with us. I am going to hand over the session to him.
Thank you. Thank you. Saira, please check whether I am audible or not.
Yes, sir, you are audible.
Okay. Thank you. Thank you very much. At the outset, let me congratulate the data science department of the TGP-CET, the coordinators, Ms. Saira Bano and another coordinator, Dheeraj Karvatkar, and the institute authorities and the head of the department, Professor Abhimanyu Dutonde, for taking the initiative to organize the faculty development program for the benefit of the teaching fraternity. AICT has funded many more programs, this time for the online mode, and this is the very good activity which is being initiated particularly in the evening time. So today's my topic of discussion, my expert lecture, it will be on the design of machine algorithm for the online emission measurement of the from the two-wheeler or from the vehicles. So let me share my screen. Hello.
Yes, sir.
Share option is not available to me. Is there any transfer of host is to be initiated?
Uh,
Uh,
sir,
Huh.
sir, you can forward the PPT to me. I can share it.
पानी बोल देना उसको रोमियो. अच्छा, because share option is not available.
Sir, there is an option present now.
No, you are the host. If you can make me host, then I can share, I think. Is it like that?
No, sir, you can share your presentation.
With the entire screen, no?
Yes, sir. Yes, sir. There is various buttons available at the down. There is
Yeah,
one
yeah,
button
but
present now.
that share tab is not activated. Share tab, I am unable to get the share tab.
Sir, actually, you have to open your presentation first.
Already opened.
Then click on present now. There is one window. There will be one window. Chrome tab, Windows and entire screen. Click on Windows. You will find your
Yes.
presentation there.
Present now. Then
Uh,
entire screen.
Go to Window. Yes, sir.
Window.
and yes, sir.
Shall
Window,
I
After
window.
select the
entire
window
screen,
option?
you can select the PPT directly open. You can select entire screen. Once you selected entire screen, after that you have to choose PPT
Now it
slides.
is coming. Huh? Now it is
Yeah.
coming. Just a minute. I hope you are able to see my presentation. Yes, please check whether my presentation is visible.
No, sir, it is not visible yet. Yes,
Now
sir.
it's
Now,
visible, sir.
Now visible? Is
Yes,
it
sir. Yes,
rolling
sir.
down?
Yes, sir. Yes, sir.
Okay, okay. Thank you.
Thank you, sir.
So today, in this particular FDP, today we will see the machine algorithm, design of the machine algorithm for IC engine emission prediction. पानी इकडे ठेवणार बेटा. So we will see what is the need of the machine algorithm, why it has been developed, and for an IC engine measurement, emission measurement, why it is being required. So contents of my presentation, the introduction will be there. Okay, then motivation, basic idea and the methodology, experimental setup which you have developed, experimentation and result analysis, attainment of research objectives, conclusions, future scope, and the references. So this will be the flow of my presentation. Okay. So in recent years, the air pollution is becoming an important issue in the India and around the world. And air pollution, it is basically creating detrimental effects onto the human health and the atmosphere. The emissions, they are basically associated with the transport. They are representing a major component of the air pollution, and it is being stated that in the reports of the government of India that India is the world third largest emitter of greenhouse gases after China and the United States. Okay, this is reported in the China's 2019 report, and you know the situation of the country, what is happening in the country at various places like Delhi, like Bangalore, Mumbai, and everywhere. And the quality of the air, it is getting deteriorated day by day. Now, what are the sources of the air pollution? If you look at the sources of the air pollution, then you will find that industries are the 23% contributors of the air pollution, because we have a thermal power plant, we have nuclear power plant, we have the many industries which basically exhaust their fumes or exhaust the things to the atmosphere, directly to the atmosphere. Then commercial and residential buildings, they create around 13%. Agriculture sector again 10% is there. Transportation 28%, and electric power it is 25%. So the report has been taken from the sources of air pollution of India, and it is found that the 28% of the air pollution, source of air pollution, is the transportation only. So transportation sector in India, it is expected to expand significantly as the country's population and economic growth rises. We know that the capital place of the India, that is Delhi, even we have introduced the formula for the vehicles, like a odd even number of vehicles formula was introduced. And with this odd even formula also, we are not able to control the air pollution in the Delhi. And now the winter session is going on, and in this winter season you might be knowing, and those who are from the Delhi, they also be knowing that they are also aware that what kind of air pollution is there in the country, entire country. So these are the some of the pictures which is being taken from the Economic Times Indian Two Wheelers Makers Report. And in developed countries where cars are predominantly used for personal transport, motorcycles are widely used in developing countries. So due to their cost, simplicity, and ease of operation, the motorcycles are being widely used as a mode of personal transportation in many Asian countries. And these motor vehicles, these two-wheelers, they contribute significantly to the total emission in the city. The city like Nagpur also, there is a lot of air pollution there. Now, what is the motivation behind the development of this machine algorithm, or basically monitoring the emission? You are aware that the Paris Climate Agreement, it is a legally binding international treaty which was signed by the India in 2015, and there are certain commitments which are being included in the Paris Climate Agreement. And as per the Paris Climate Agreement, which was signed by the India and which we have entered in for November 4, 2016, it is obligatory on a part of India to bring down the carbon emissions into the atmosphere, and its level should be reduced down, so that the future generation of the India should get non-polluted air, and the global warming, or we can say that the greenhouse emissions are being reduced down, and the entire earth can be saved because of that. So the conventionally, most of the time, the dynamometer testing, it has been widely used to measure vehicle exhaust emission, and these measured emissions have been used as a primary data for modeling the transport-related air quality impact. However, the conventional emission testing and real driving conditions are not strictly considered. For example, when you purchase the vehicle, that time the vehicle average which is being tested, which is being given under the room conditions of conditions like Indian road conditions, it may not give a 50 to 60 mileage, and it may be reduced down to certain 40-50 or 30-40, which means that even on the background of this one, the vehicle emissions which is being projected into the when we are purchasing the vehicle, that kind of projected emissions will not be there, and more that vehicle is emitting onto the road condition. So studies on the automotive exhaust emission under real operating condition, they have clearly demonstrated that the level of natural waste emission is higher than the level of laboratory test emission. इसका मतलब ये है कि हम जब गाड़ी खरीदते हैं तो गाड़ी का जो एवरेज बताया जाता है, वो एवरेज से गाड़ी हम एवरेज देती है, उसी तरह से गाड़ी के जो पोल्यूशंस को जो डिफाइन किया जाता है कि गाड़ी का इतना इतना पोल्यूशन रहेगा, BS6 नॉर्म्स है हमारे यहाँ, अभी BS6 नॉर्म चल रहे हैं, तो BS6 नॉर्म से कॉम्प्लाइंट रहेंगी. व्हेन इट कम्स टू द रोड कंडीशंस, द व्हीकल emit more than what is being required, what is being permitted as per the regulatory authority. So let us come to the portable emission measurement system. So this type of portable emission measurement system, these are available like ABL, Horiba, then Semtech DS analyzer. So despite the fact that PEM is labeled as portable, it normally weighs more than 100 kg due to the presence of gas cylinders for calibration and batteries. This weight has an impact on the driving. The cost of the MEMS is more. So let me have the interactive lecture, and let me check that इस तरह का आपने emission measurement system देखा है क्या, और आपने ये यूज किया है क्या. You are able to see the 5-gas analyzer system which is being shown onto the screen. Okay, so let me check whether you have used such kind of system or not. Can anybody speak? Yes. There are around a good number of participants. 82 participants are there for this FDP. Can anybody tell me that जो मैंने स्क्रीन पे दिखाया था वो जो है, वो आपने कभी यूज किया है क्या? इस तरह का पोर्टेबल एमिशन मेजरमेंट सिस्टम, इस तरह का कुछ यूज किया है?
नो सर.
नो सर, नहीं यूज किया. किसके किसके पास में 4 व्हीलर है? 4 व्हीलर फोर व्हीलर नहीं है किसी के पास में?
I don't have, sir.
No, sir.
Four wheeler, out of 80 participants, nobody is using the
No,
four
sir.
wheeler.
No, sir. We are not used.
Okay, टू व्हीलर्स किसके किसके पास है?
I have, sir.
सभी के पास है। पोल्यूशन टेस्टिंग जो है, पोल्यूशन नॉर्म का टेस्टिंग, वो तो इंडिया में मैंडेटरी है। Are you getting me? Pollution testing? Yes, it is called as the PUC testing. Rupali Bhakte. Yes, Rupali. PUC testing, have you used or not? Rupali? Arvind is saying yes. So you people, you have used the analyzer, 5-gas analyzer, which I am trying to show you on my screen. Okay. So this kind of 5-gas analyzer you have used. Under this 5-gas analyzer, we say that Pradushan Chachani, which means that for only the fine which is being applied by the traffic police, fine which is to be applied by the basically by the RTO, we do the PUC testing. Okay, basically the purpose of the PUC is that in a 6 month span of time, we should service our vehicle and we should obtain the PUC certificate. And with this PUC certificate, it is being guaranteed that your vehicle is not emitting the exhaust gases beyond the permitted limit of the environment, which means that BS4 vehicle है, compliant vehicle, या BS6 vehicle है, तो उससे ज्यादा एमिट नहीं कर रहा है, वो पीयूसी सर्टिफिकेट से गारंटी मिलती है। सो इन सच केसेस व्हेन यू वांट टू यूज 5-gas एनालाइजर, we have to take this vehicle, you have to take this vehicle to the stationary system, stationary 5-gas analyzer. It is not online monitoring नहीं हो रहा है इसमें। हम लोग अपना व्हीकल लेके जाते हैं, देन sensor based system is there. Sensor is inserted into the silencer or exhaust pipe of an vehicle. We start the vehicle, accelerate the vehicle for some time, and then testing is being done, and then give the PUC certificate. What does it mean? PUC certificate means it is being certified that your vehicle is not emitting the above beyond the norms, okay, beyond the norms of the environment which is being specified by the government of the India. So that is being ensured, that is being guaranteed. For this purpose we use that. So this is a steady system, stationary system, wherein we are supposed to take our vehicle to the station where the PUC testing is being done. So what are our objectives? Our objectives are to develop the portable real-time emission sensing device for a two-wheeler. Okay, हमारा ये objective था कि online real-time sensing device design किया जाए to measure the real-time emission from two-wheeler with the help of emission sensing device for different blends of gasoline and ethanol, to investigate the effect of ethanol gasoline blends on two-wheeler emission, to develop the two-wheeler emission prediction system using the machine learning model. Okay. So what is the methodology which you have adopted? The methodology which you have adapted basically literature review, then research gap. Okay, then we have defined our objectives, then selection of biodiesel, then development of sensing device, planning of experimentation, result analysis, and the conclusion. So we have used the ethanol. Hello. Hello. मी नंबर लावून जाऊ म्हटलं ना आलं नाही. So today India imports about 85% of its oil requirement. It is being made through the imports only, and ethanol is the principal biofuel which is being used, and we don't have the oil reservoirs sufficient for the requirement of the India. So according to the reports published in June 2021, Roadmap for Ethanol Blending in India 2020 to 25 by Niti Aayog and Ministry of Petroleum and Natural Gas, the target of 20% ethanol blending in petrol in the country by 2025. Hence, a successful E20 program can save countries US $4 billion per annum, means around 30,000 crores of rupees per year for procuring the vehicle, procuring the oil. क्या है पेट्रोल डीजल लाने के लिए. So what we have done that, अभी मैं again I will ask one question to you, that how many types of signals are there in our vehicle? Signals are there in our four-wheeler. कितने प्रकार के सिग्नल्स होते हैं? सीट बेल्ट नहीं लगाया तो अलार्म सिग्नल होता है. When you don't have the seat belt, when you don't tie up the seat belt, that time is there any alarm in the vehicle? Let it be somewhat interactive.
Yes, sir. Yes, sir. Seat
हाँ,
belt ना लगाने
yeah,
से
please
alarm
tell
बजता है.
your
जी,
name. Yeah, can you please tell your name?
Myself, Argodeep Sen.
Okay, from which college?
I'm studying from Aicte University, which is in Bhubaneswar. I'm currently working in SBUP, which is in Pune, Sri Balaji University, Pune.
Okay, very good, very good. So, sir, you know that when there is when you don't wear the seat belt, that time the signal will be developed in the vehicle. Okay?
Yes, sir. Yes, sir. There is an alarm.
Similarly,
Yes.
yeah. Similarly, when engine hits beyond its predefined limit, there is a signal, there is an alarm into the vehicle.
Sir, I haven't experienced that, but there might be.
Okay,
Sure.
okay. ठीक है. Is there any signal of reserve category? Means when the fuel is less, reserve is there?
I think there is a color indicator or something.
Yes,
on
color
the
indicators are there.
vehicle.
Yeah.
Yeah.
Now we will come to the point that in the vehicle dashboard, there are so many indicators which is being fused, and the systems has been developed in which, okay, if the engine is overheated, there is a signal into the dashboard. If you don't wear the seat belt, there is a signal. Okay, alarms will be there. Similarly, okay, if oil is less, even tire pressures are less, then also there is a signal, which means that there are so many systems which is being developed and made available into the vehicle dashboard. But as such, there is no system in existence in our country, in our vehicle, wherein there is no need to take the vehicle to the PUC testing and online monitoring of the emission is being going on. इसका मतलब ये है, what we are trying to invent and devise, that online monitoring of the pollution, online monitoring of the exhaust emission will be there. If the vehicle emits the permissible limit of the environmental constraint, then in that case, in the vehicle dashboard, the alarm will be there, signals will be developed. So like this type of system we are trying to develop. So let us come to the slide again. And now you can see that we have developed the Android mobile app, and this is the development of the sensing device. On right hand side of the screen, you are able to see the screen of the mobile basically, and onto the screen of this mobile, the Arduino system gas sensors which we have used is MG811, MQ7, then MQ135, then MQ2, and Bluetooth Arduino is used. These gas sensors detects the pollutant such as carbon monoxide, carbon, then the nitrogen, hydrocarbon, and carbon dioxide. So these data, it is being recorded, and sensors data, it is being stored, it is being monitored through the mobile app which is being developed by us. So for this purpose, we have done the programming, gas sensor programming we have done with the help of the Android app, and then we have implemented it into our bike. So this is the basically screen of the mobile app which is being developed. In this screen, you are able to see that real-time two-wheeler emission prediction system, that load under which the vehicle is working, speed, and the ethanol concentration. And onto the mobile screen, we are able to predict CO2, NOx, and the HC, hydrocarbon. And for this particular device, that is two-wheeler emission measurement device, we have filed a patent, and patent is granted to us for this particular device. इसका मतलब ये है कि अभी कोई सिस्टम हमारे पास उपलब्ध नहीं है जो सिस्टम में हम लोग ऑनलाइन गाड़ी जब चल रही है तब व्हीकल का पोल्यूशन एमिशन मेजरमेंट कर पाए. तो हमारे डिवाइस में जो हमने डिवाइस डेवलप किया है उसको माउंट करने के बाद में ऑनलाइन जो प्रोग्रामिंग किया गया है, जो सेंसर्स लोकेट किए गए हैं, वो सेंसर से ऑनलाइन में थ्रू मोबाइल ऐप इनटू द क्लाउड द डेटा इज बीइंग सेव्ड, एंड दिस डेटा which means that when it exceeds the permissible limit of the environment, the signals will be developed. So this is the design of the emission sensing device. MG811 sensor, MQ7 sensor, MQ135 sensor, MQ2 sensor, and this is the real-time emission sensing device where GSM module and the Arduino Atmega 328 controller is being used, and Android app is being developed. So these are basically the pictures of the Arduino MQ135 sensor which we have used in our project. MG811 gas sensor, MQ7 gas sensor, MQ2 gas sensor, SC05 Bluetooth sensor. These are the various components which we have used in our real-time exhaust gas sensing system. CO2 gas sensor, CO sensor, N2 sensor, and SC sensor. These are the basically technical specification of the Arduino Uno R3 which we have used here. Okay. Technical specifications of the MQ7 gas sensor. Technical specifications of the MQ2 gas sensor which is used for measuring the hydrocarbon. MG811 CO2 gas sensor which can measure the basically carbon dioxide percentage, carbon dioxide into the emission, exhaust emission. MQ135 sensors which is very high sensitive to the nitrogen. So nitrogen gas sensor is being used. Then this is basically the mounting of the emission sensing device onto the two-wheeler tailpipe. So you are able to see that two-wheeler, onto this two-wheeler, the sensor system, it is being mounted and the data is being recorded into the mobile app. So you are able to see the basically the mounting of this device. So this is mounted onto the silencer, means tailpipe of the two-wheeler, And on one of the picture, you are able to see that the communication of the device with the mobile through the Android app, which is being developed by us. Okay. So how we have done it? We have done through the DOE. We have applied the design of experimentation. We have conducted the experimentation onto the actual road condition, wherein in stage 1 and stage 2, we have used the full factorial method basically for the DOE, design of experimentation. Experiments were conducted at different path, fuel provider, and the fuel blends. We have identified the independent and the dependent parameter like emission of CO2 and variables like load on the bike, speed of the bike, and use of biodiesel, because blending of ethanol is there. So in this blending of ethanol, we have used the various combinations of the ethanol. Then test planning was done with respect to the parameters which are identified, and then we have formed the test matrix basically. And with respect to this test matrix, which displays the 27 order experimental conditions, experiments were carried out. Now, experiments were carried out in the two parts. The first part is in laboratory by using the AVL gas analyzer and real-time exhaust gas sensing system. And in part 2, on-road real driving conditions using the fuel from Hindustan Petroleum, IOCL, BPCL, and the fuel provider. So first thing is that device was tested in the AVL gas analyzer, and error analysis was done with respect to the standard gas analyzer, and then on-road in the on-road condition it is being tested. So in the part 1 method, basically we have in the laboratory we have conducted the experiments for the effect of load and speed, effect of load and biodiesel, effect of biodiesel and speed. Okay, this is the experimental setup which we have used for the emission measurement. And these are the gas analyzer which you are able to see, that AVL exhaust gas analyzer, AVL smoke meter, okay, which is being used even in the stationary condition, in the laboratory condition. So our researcher, our candidate who is working in the laboratory for preparation of the in the laboratory for testing of the exhaust gas analyzer. Hello. हो सुरू आहे सध्या, बोल ना. नाही, क्लास झाल्यावर फोन करतो. नाही, येतो ना. So error finding in emission sensing device. Then we have calculated the error by conversion ppm into the gram per kilometer. Okay, and this is the measurements which you have carried out at gasoline ethanol blend at different speed at different load, and these are the effects which you have studied for the CO2 emissions. Error, once we find out the error, because for further modeling of the machine algorithm, we require the errors in the device. So for a biodiesel variation, for a speed and for the load, for each of the sensor, the errors are being plotted in percentage. Then in the part 2 condition, part 2 of the experimentation, on-road effect of different petrol pump fuel on CO, CO2, N2 and hydrocarbon emissions was done. Effect of speed on CO, CO2, N2, SC emission for E10, P90 diesel, effect of CO, CO2, N2 and SC emissions for E15, P85 biodiesel. Okay, and we have used the 3 different types of the petrol pump, because density of the fuel supplied by the petrol pump, it also varies. So HP, Indian Oil and Bharat Petroleum. This is according to the blending which is permissible, that in present study we use the ethanol as a biodiesel blended with gasoline 10% and 15% by volume, and investigate the effect of ethanol gasoline blend onto the vehicle emission. So on-road experimentation which you have carried out, this is you can see here this is the map of the Maharashtra state. Under this map, Maharashtra state, there is a Bandara Tahsil map, Bandara district basically, which is around 60 to 80 kilometers from the Nagpur. And Bandara is situated at an latitude and longitude of 244 meters from the above the sea level. It is located on National Highway 53, which connects Mumbai and Kolkata. And Bandara is also called as the city of lake, brass city, since it is having the 3,500 lakes in the Bandara district. So it is the Maharashtra city of lake where we have conducted our experimentation. So this is the vehicle population in Bandara district. We have taken this database from the government office that motorcycle, there are around 1,23,000 motorcycle, mopeds are 20,000, cars are 10,000, tractors are 10,000, and jeeps are 2,924. Because the density of the air pollution, it also matters. Auto rickshaws are 238. Buses are around 211 buses are there for a Bandara district. This is our study area map. On a Google map, you can see that we have selected the 3 different areas in the Bandara district, that is Shahpur to Satona, Satona to district collector office, and district collector office to the Shahpur. Okay. And these are the 3 different areas where the driving conditions are also different: urban, rural, and the motor highway. And Honda Shine vehicle, the newly purchased vehicle, was used by us, which is basically the BS6 compliant vehicle, and technical specification of the motorcycle, it is being given. The driving conditions which you have observed, we have driven the vehicle with a variation of 25 km to 35 km per hour, 35 km to 45 km, and 45 km to 60 km per hour. These are the 3 petrol pumps which you have used: HP petrol pump, Indian Oil petrol pump, and the Bharat petrol pump. And these are the fuel station location. On Google Map, you are able to see that these are the fuel stations which we have used. Okay. Then the testing which you have carried out on Monday, Tuesday, because crowd on the road, how many times you are applying the brake also, it decides the basically the pollutants quantity, quality. So Wednesday, Thursday, Friday, Saturday, like that. Okay, these are the shifting of the gears which you have used under the vehicle speed. Then this is the sample data which is being recorded onto the cloud with the help of the sensors which is located in the online monitoring system. And then we have discussed our results. Now here I will not discuss the result, what is the effect of each parameter onto the various conditions. But CO2 emissions, it is an increasing trend with the addition of ethanol. As the ethanol percentage goes on, the CO2 increases. Okay. Then nitrogen, NOx emission reduce on adding ethanol to the gas. So CO2 increases, but N2 it reduces. Similarly, you can see that unburned hydrocarbons are the hydrocarbons emitted after the petroleum is burned. So it is reported that unburned hydrocarbon decreases with the increasing amount of ethanol in the blend. On-road vehicular emissions, which we have measured: CO2 emissions, CO emissions, N2 emission, and then PUC testing certificate, which is being added. Okay. Then compared the stationary conditions with the real-time conditions and converted, and on-road emissions from motorcycle at a speed of 50 km per hour, it is being calculated. So these are the on-road emissions: CO2 12 gram per kilometer, CO 0.59 gram per kilometer, N2 0.001578 gram per kilometer, SC 0.001678 gram per kilometer. and data collection and prediction system. So total readings on various routes were collected at 14,000. But we know that the mathematical modeling, the model developed with the existing data only. In order to update the data, again, new model is to be developed, and it takes a time again and again. So with the 14,000 data, we have basically prepared, we have used the algorithm to predict for the emissions. Like a machine algorithm, which we have used. Machine learning is used for a variety of tasks like a fraud detection, predictive maintenance, portfolio optimization. Okay. The core objective of the machine learning is learning and inference. First of all, the machine learns through the discovery of pattern. This discovery is made thanks to the data. One of the crucial part of the data scientist is to choose carefully which data is to be provided to machine. The list of attributes used to solve this problem is a vector feature. Okay. These are the steps in the machine algorithm. You know that in the machine algorithm, we are trained and tested using experimental data, which we have recorded, data set definition, extraction, transformation on loading, machine learning, model formulation, select the best prediction model. Okay. The total load, speed, and biodiesel composition were used as input, and the output were composition of CO, CO2, N2, and SC in the exhaust gases. So preparing the data, then choosing a model, and then training and the evaluation, and then finally hyper tuning of the data, and then prediction. Okay. So in the machine algorithm model, basically there are four types of machine algorithm. One is linear regression, k nearest neighbor, decision algorithm tree, and a random vector functional link. So variety of machine learning methods have been published and in the literature by the various academicians. So four machine learning techniques, that is support vector mechanism, decision tree MIDI, and k nearest neighbor are the examples of random vector functional link. And we have explored that in our study in order to discover the best one. So this is the linear regression machine algorithm. Already you are aware about the linear regression. Then k nearest, where the vote by the three nearest neighbor, k nearest neighbor. Okay, so it is crucial. Then decision tree: should I accept a new job or not? So this is the basically the decision tree model. Then random vector functional link, random forest regression uses ensemble learning for regression. So random forest is an accurate regression model. It frequently produces outstanding results, particularly on non-linear difficulties. So the out of this machine algorithm which is being used, we have trained the our data 14,000 readings which we have taken, and then we have tested it, and we found that for a prediction of CO2, linear regression algorithm was used. For prediction of CO, k nearest neighbor algorithm was used. For prediction of N2, decision tree algorithm was used, and for the prediction of hydrocarbon, random vector functional link, it gives the best result. Okay. Then in our research data set, 9 combination of engine emission was available from the IoT technique. This data set contains 7 main information like a density of the fuel, speed, ethanol, percentage in petrol, carbon monoxide, carbon dioxide, nitrogen oxide, and hydrocarbon. So our goal was to create that model which can easily determine the emission of different gases at different cooling conditions. Since we need to find out the emission at different gases, so they are the dependent variable and other 3 variables are independent variable. So data for processing steps, fitting the machine learning model to the training set and predicting the result of the test set. So this is the linear regression model which we have used. Okay. Then different models which we have used, and R means square value, root means square value calculated, and then this screen which is available onto the mobile screen, which you are able to see that they are able to predict with the help of the sensors data which is being recorded. So in conclusion, we can say that as ethanol percentage is increased by 15% in commercial gasoline during real-time emission measurement, the following observations are found out. As ethanol percentage increases from 10% to 15%, CO2 emission from two-wheeler is increased by 6% to 7%. CO emission from two-wheeler is decreased by 2% to 3%. So therefore, adding 15% of the ethanol to commercial gasoline has a significant impact onto the CO2 and CO emission. The emissions of above parameters were recorded by using a standard AVL gas analyzer and developed instrument, and the results were compared. It has been found that the developed instrument has an accuracy of 93.57% compared with the AVL gas analyzer. So finally, we come to the conclusion that the ethanol blend of petrol at 15%, which gives the emission of this much. Okay. So what is our scope for future work, and what is our purpose of undertaking this study is that in the current research was to develop for detecting only 4 gases. The research gap can be done for improving the accuracy of the system. And finally, we would like to bring the alarm system into the vehicle dashboard. If your vehicle is emitting than the permissible norms of the environment, then the alarm will be developed into the dashboard of the vehicle. If the vehicle bring the message which is given by the vehicle, then to your registered mobile number, message will be through this algorithm. And then if you are continuously ignoring the message, in that case, directly the message will go to the RTO for taking an action against the vehicle which is emitting more than the permissible limits of the environment. These are basically the papers which you have contributed onto this particular area. This patent which is being granted. This is the portable attachment which you have developed. Okay. These are the various locations where we have tested our device for online measurement. I hope you are able to see this video. Okay, kindly see this video and give a feedback to me. I hope you are able to see my video. In the video, I have shown that the vehicle was mounted onto the portable attachment as a portable attachment. You can see that vehicle. Online measurement was being done, and this online measurement, which was being recorded into the cloud, data was stored into the cloud through the mobile app which is being developed. So this researcher has shown you the mobile also while driving, which is basically recording the database. Okay. This is laboratory testing. This is road testing. And we have presented our device, which was appreciated by the amongst the various innovators, which was available at the G.H. Raisoni College of Engineering, Nagpur on 29 July 2022. So these are the references of our study. So main reference is basically PhD thesis, comprehensive work done by Mr. Dr. Shrikant Bande lecturer in mechanical engineering at Government Polytechnic, Sakoli. So these are the permissible limit BS6 norms in India. And if the vehicle is emitting above the norms, if the vehicle is not serviced and maintained, then in that case there is no such alarms are there into the vehicle dashboard, and we would like to have that in future. So these are the various types of alarming system fusion vehicle dashboard, but no signal, no feedback is taken for the environmental concerns. These are the books which is being authored by us, authored by me. Okay, additive manufacturing and 3D printing, automotive manufacturing process, ethics in information technology, which may be useful to your students, automotive systems also. These are some of the books again authored, that is strength of material, mathematics for computer graphics, hydraulic machines, computer graphics and all. So thank you very much. Thanks a lot. Okay. Thank you very much. Over to the organizers. So let me
Yes,
go
sir.
to the organizers.
Yes, Saira madam.
If any questions are there, then we can
Dear
take up some
participant,
questions.
is there any questions? Sir is available for the question answer sessions. So, is there any questions? You can raise your questions.
Sir, this experiment was conducted for only two-wheeler vehicles, right?
Yes, this experiment was conducted for a two-wheeler and device which you have developed basically for the two-wheeler, on which patent is granted to us for this device.
Okay.
And in future, we are trying to have this kind of system, sensing system, online sensing system, and its signal fused into the vehicle dashboard, even for the four-wheeler. जैसे कि आपने अगर सिग्नल क्रॉस किया तो सिग्नल जंप किया तो आपके घर में चालान आ जाता है with the help of
Yes,
the
yes,
CCTVs which is being placed. Similarly,
yes,
एनवायरमेंट के लिए हमारे यहाँ कोई कंसर्न नहीं है. हमारा व्हीकल
yes.
रिपेयर किया नहीं किया तो भी कोई चालान नहीं है, कुछ सिस्टम नहीं है. तो ऑनरेबल मिनिस्टर हाईवे एंड ट्रांसपोर्ट मिनिस्ट्री दे विल बी काइंड ऑफ सिस्टम. इसमें हम व्हीकल के डैशबोर्ड में एक सिग्नल्स देंगे जिसमें ऑनलाइन
जी सर.
मॉनिटरिंग करके आपको पता चलेगा कि आपका व्हीकल जो है परमिसिबल नॉर्म्स के ऊपर एमिट कर रहा है. Okay, and
जी
you
सर.
need to repair and maintain your vehicle. So we are looking for that kind of systems. और व्हीकल के डैशबोर्ड में अभी इतने सारे अलार्म सिस्टम्स है, सीट बेल्ट से लेके
जी
जगह जगह,
जी सर.
लेकिन कोई सिस्टम नहीं है एनवायरमेंटल कंसर्न का, वो हम लाना चाहते हैं.
बिल्कुल बिल्कुल. Thank you for the session, sir. It was a wonderful experience.
थैंक यू. एनी अदर क्वेरी? थैंक यू सर. थैंक यू
Yes,
प्रसाद सर.
yes, dear participant, is there any query? You can raise the query. Okay, I think so. There is no question, sir, from
ओके,
participant A.
फोटोग्राफ
So,
ले लो और फिर क्लोज कर देंगे.
yes, dear participant, I request you all kindly on your camera for the photo session. I request all the participants please turn on the camera for the photo session of this session. Yes, I request all the participants, those who are present in the meet, kindly switch on your cameras for the photo session. Sudha madam, please take a screenshot of the session. Sarah madam, take a screenshot of photographs session. Okay, thank you. Thank you, everyone. Yes, thank you, dear participant. So, I thanks to Avari sir for your wonderful session and very informative sessions related to the environment to avoid the pollutions in the environment, and for that reasons you are developed such a great model for the environment to maintain the environmental emission of the carbons and different gases from the vehicles. So on behalf of the organizing team, I thanks to Dr. GK Avari sir for your valuable insights. And also I thanks to all the participants, those who are listening patiently and joining every day, all the sessions and attending the FDP. Thank you. Thank you so much, sir.
Thank you. Thank you.
I request all the participants to please be remain online as our second session will begin at 8 p.m. All participants fill the feedback form of first session of day 5. The link is sent in chat box